All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Looks like we are live and ready to go. So, the plan tonight is to pick up where we left off last time, but before we jump into that, I do just want to take a quick second and thank the supporters of the channel, beginning with our first elite partner, who is Javier Olazaran. I'd also like to thank the partners, who are Furkan Tokan, Matt Oscard, and Gaboles Inc. Those are the highest tiers of subscription over on YouTube memberships and Patreon. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. I don't have any sponsors or things like that. It's just you guys, so I greatly appreciate it. In addition, I would like to also thank all of you who are here either joining me live, either on Twitch or on YouTube. We simulcast both, as well as all of you who are catching the VOD after the fact. Without you guys, this project would not exist, so thank you guys very much for being here. I appreciate each and every one of you. All right. Widgler, hello, how's it going? Good to see you. Okay, so like I said before, we're picking up where we left off before. I've actually gotten quite a bit accomplished off camera. So we're going to kind of try to step through that somewhat quickly. Let me quit out of this. And we'll do a git log real quick. So I went ahead and pushed in all of the stream work that we did. I also reworked the Vulkan backend to use handles for both textures and samplers. And then I had here work in progress shader system conversion to handles. And so that shader conversion or shader system conversion to handles has actually been completed. And so as a result, we have a few different things that have changed in the way that we handle shaders. So the shader struct itself no longer exists outside the shader system. So you won't find it here in the code base. We don't deal with shader pointers anymore at all either. We also don't have a concept of the sort of void pointer shader internal data anymore. That's gone as well. And so everything having to do with shaders, it goes through handles now, right? So whenever we create a shader using a config, we are given a handle back, and we use that handle to refer to the shader from then forward. And we also did away with, we used to have this sort of shader ID system, which was just an integer. That concept has also been replaced by handles. So there's some places in the code base where we're going to have to update that. But we're now using the handle system. And the reason for that is because the handle system didn't exist when we created the shader system initially. So now the shader system is another prime example of how we're going to use handles for basically everything eventually. And so the advantage there is that we don't have to worry about dangling pointers. We can check for invalid or stale handles and handle it gracefully, pardon the pun. And that's going to just make things a lot nicer to work with, right? We don't have to worry about pointers all over the place or ownership or any of that stuff. Everything is owned by the shader system. In addition to that, within the shader system itself, if we take a look at the internals of it, and we go to the top here, we could see that our K shader is what it's called now. Our K shader is internal to the shader system, right? So that's the only place this struct exists. There's probably still some more stuff that I want to come in here and clean up, but all of that's going to be internal at this point. In addition, we have a separation. You'll notice that we don't have a internal data in here anymore for shaders. We used to have like a void pointer internal shader data, and that would get passed around between the front end, the back end, and of the renderer rather. And it was kind of a mess, right? We had these sort of references in both directions, and that really was kind of terrible. So we've done away with all of that. And the way that this works is our internal shader system state now has an array of shaders, right? K shaders. and each of those K shaders has a U64 unique ID. So that matches up to the unique ID that is in the handle when the handle is created, and that's how we verify that the handle is indeed valid and not stale. So we do need to add that validation in here in a few places, but for now, it looks like it works pretty well. The other benefit to this is because we have this concept of handles in the shaders, the renderer actually also uses the handles to refer to shader internal data as well. So if we take a look at the Vulkan backend, I guess we could go to, we still have the Vulkan shader concept, right? But now that is held within the context as an array. So just like what we have on the front end, we also have on the, or I should say in the shader system rather, we have an array of K shaders. Within the renderer backend, we have an array of Vulkan shaders. And these are referred to by the same handle that is used by the shader system. So the same indexes line up in both cases, which makes it really convenient. So we don't have to have two separate handles. We can use the same handle to reference both pieces of data and keep those pieces of data separate from one another. So we don't have to worry about who owns what. The Vulkan renderer owns all of the internal Vulkan shader data, and the shader system owns all of the generic or system-wide shader data. So we have that separation of concerns, and this is kind of what we're going to move towards for a lot of other things. So we have this concept for shaders. We also have this concept for samplers, so that works pretty much in the exact same way, as well as textures, right? So texture internal data is now handled the same way as well. We don't have sampler or texture pointers being passed back and forth between the renderer front end, back end, and any other system. We use handles for all of it. So that has been quite convenient to use, and it's coming together nicely. So let's see. Let me catch up on comments here. Doing well, almost on 3D for my engine renderer. Nice. That's awesome. It's always exciting when you get that working for the first time too. Okay. So we have that. The concept of a sampler outside of the renderer is now nothing more than a handle, right? We still do have like K-resource textures that are used by the system, and those will be passed around for right now. We might convert that to handles as well. But as far as communication between the front end or the texture system and the renderer, everything goes through handles. In addition to that, I did a lot of code cleanup in the back end around descriptors, got rid of a bunch of duplicated code rather, and just generally cleaned things up a little bit and made it a little bit more, a little bit nicer to work with, right? So I'm still in the process of cleaning some of this up, and we only do have actually one error left in here, and that's something that I'm going to try and resolve tonight. So we also have, I believe, the separation between our sampler descriptors and our texture descriptors and states for those. All of that has been separated too. So the concept of a texture map that we had, which was sort of the combination of those two, that's been eliminated, and we handle those things separately. And so most of that is done, including the ability to get a default or generic sampler. We looked at that on the last stream. So we've actually put that into use with a to-do to allow us to configure that, right? So by default, it just uses the generic sampler, but for all sampler descriptors. But eventually we're going to want to be able to configure that, right? We can set it up in the material setup or configuration. So we need to eventually add that. But I wanted to get it working with just the generic sampler first, and then we'll go from there. Okay. Textures are going to work pretty much the same way. The only difference is is we don't have a concept of a sort of default texture within the Vulkan backend. So we do have that array of textures that we can pull from, but we don't know which one of those is the default, right? And so we need some way for our texture system to tell the Vulkan renderer, ultimately, or the renderer, hey, these are your default textures of these individual types. So that's a to-do on the roster tonight, so we can fix that up. And that should actually tie up the Vulkan backend quite nicely in terms of what we need to do. And then we're going to resume work on basically refactoring our material system in its entirety. So we wanted to get all the sampler work and all the texture work and the shader work done because the material system uses all three of those things. So now that we have those things straightened out, I think we are at the point where we can actually do that. So I'm going to tackle this first, and then we'll circle back to the material system. Galactic Past, how's it going over there on the YouTube side? Welcome. I should add also, this is an interactive stream, so if you guys want to chime in and say hi, or if you have any questions, feel free to drop them in chat, and I'll answer them to the best of my ability. It's LaChico, first time chat. Welcome. How are you doing? Hope you're doing well. Welcome to the stream. All right, so I think the way that we need to approach this is if we take a look at the renderer front end. I actually have a note here, right? We need some way to maintain handles to default textures. So the way that we handled this for generic samplers, right, which is this collection of pre-configured samplers, is we just have an array of those things, right? Which in this case is just 8 of them. And we index those by the generic sampler enumeration, right? And then we can query them by that. Straight from the front end, the back end doesn't even need to know anything about it, right? And that all works, again, if we look at what this actually is, it's an array of handles, right? So again, we're just dealing with handles here. So I'm thinking our default textures should probably work the same way with a few different configurations. So my thought is we should probably figure out what type of textures we want to talk about when we're talking about like default textures, right? So what we're going to do is we're going to say type def enum, and we're going to call this, let's see, this is core renderer types. So let's call this renderer default texture, right? Default texture. And the reason we're calling this renderer default texture is because the texture system has its own sort of default textures, but the renderer sort of needs its own set of default textures as well. And those two may overlap and probably will overlap. But we need a way to specify to the renderer when we create these default textures what we want to do, or how we want to assign them, right? And so we're going to have things like, let's say, renderer default, texture. And the first one is probably going to be, what do we want to call it? I guess base color, right? And so this one is going to be used as a default for material base colors, right? So we had in the texture system, we had sort of a default albedo or default diffuse. This is sort of going to line up with that, right? And we'll probably wind up renaming that in the texture system. So another one is if we just think about materials for a second and some of the defaults that we're going to need. So we'll say renderer default, default texture, and we're also going to have normal. Right, so that's one, and I'm actually just going to duplicate this a few times so I don't have to type that whole thing. And then do that. Okay. So render default texture. Let's see. We're going to need a default MRA text. Well, let's do metallic, right? Roughness. Ambient occlusion, right? And obviously we need to change the indices for these. Forgot a comment here, comma rather. All right, so we have that. I guess we could do emissive. I'm not sure we didn't need a default texture for that, but let's go ahead and add one anyway. And we'll also do a DODV for like the water, right? So right now we're sort of loading that off disk, but eventually I think we should probably find a way to generate one of those. So let's replace that with 6. And I think that's enough for now. We can always expand on that. And then what we'll do here is render default texture count is the last element of that, right? So we know how big to make the array. Okay, let's see. Dead Martyr, how's it going? Good to see you and welcome. Seen your videos pop up in my feed a lot in the last few months. I think it's really impressive to have the dedication to put so much time into things like this. First time here. Well, welcome, and thank you very much for the kind words. I appreciate that. Yeah, it's taken quite a lot of work, I'm not going to lie. I wish I could get further faster, but, you know, it's only a part-time thing for me. What are the minimum hardware specs to be able to run this engine? I couldn't get it to work on my laptop, which has an integrated Intel graphics. So, I think I actually have a pseudo hard-coded requirement to require discrete graphics, but I think we might actually be able to overcome that. Let's see. Actually, it looks like I already shut that off by default, unless we're... Oh, wait a minute. No. So, okay. So if you were to go to, if you pull the latest code, and you go to vulkandevice.c, and you go to, it's probably around the same line, maybe. I'm on a feature branch, so it might be a little bit different, but this line will be the same. So if you look for requirements, discrete GPU, just change this to false. And that should work, I think. As long as you have Vulkan drivers for that, I think it should work. I haven't really tested on Intel iGPUs, but in theory it should work. Question, learning Zig and think it's a good thing to learn and, think a good thing to learn is to try and implement a simple tic-tac-toe game with graphics, but there isn't like a Java effects type of thing. Where would I even begin? So what I would tell you is, check out, let me pull it up, because you can adapt this to Zig. Go to learnopengl.com. Learnopengl.com, rather. Drop the link there. This will actually give you everything that you need to get started with OpenGL. Now, you'll probably have to adapt this a little bit to Zig, but I don't think that'll be too big of a jump from C++, right? As long as you pay attention to, like, the overall concepts of graphics programming, you can get a decent renderer up pretty quickly using this. So really all you'll need to know is how to draw quads on the screen with a texture on them, and you can implement that easily. So this is where I would start, right? And then if you start with OpenGL and you get good with it, then your graphics programming will also pick up from there. So one of the disadvantages to using libraries like that, like the one you mentioned, right, is if you switch to a different platform or a different tech stack, you now no longer have that thing. Whereas if you use something like OpenGL or ultimately Vulkan, there are bindings for that for just about every language out there. And you can just build whatever you need to build, right? It's one of the reasons that we build this whole thing from scratch. Hope that helps. Nice theme. You talking about this one? Yeah, it's a mixture of my terminal theme, which is, I want to say, Adwaita, and then my Neovim theme, which is, I think, GitHub Dark. I can't remember. What I'll do though is I actually have an article on my Neovim setup. If you want to take a look at that. What do you use instead of size T? Is it U64? Yep, I just use U64. Yep, exactly. Yeah, no problem. Diamond, how's it going? Welcome. Good to see you. Magatsub, good to see you as well. And Smudge, how's it going? Let me catch up on the comments over here. Let's see. Would albedo be more accurate than base color? So the reason I go with base color instead of albedo is because we have different shading models, which is something I haven't really talked about too much yet. We're going to visit that in the material refactor that we're going to hit. But we basically have different lighting models, and they don't all take albedo, right? So I wanted something that describes sort of like a base diffuse, but also albedo, right? And so I just kind of landed on base color. That's actually what Unreal does, and I kind of like the way that that's called, right? It just kind of gives you that this is the base color of the thing that we're going to be using, and everything is just sort of integrated with that, or, you know, added on top of it. Let's see. Have you dealt with Wayland, or are you leaving windowing for X-Wayland? So X-Wayland for now. Eventually, I'll write a Wayland backend, but I just haven't had the time, frankly. And X-Wayland is doing the job. So part of the reason I haven't really gone the Wayland route also is because RenderDoc doesn't work on Wayland. So that's probably going to be a bit far out. It's on my to-do list, but it's not prioritized. Can confirm it works fine on my laptop with an Intel integrated GPU. Okay, that's good. That's awesome, Smudge. Thank you for that. Looks like there may be. So I have another OpenGL Zig resource for you. I'll drop it over here in the other chat on the YouTube side. One of our chatters over on the Twitch side dropped this for you. So have a look at that as well for Zig with OpenGL. Use that in combination with the tutorial. Library is just loading the function pointers. In general, the Zig game dev repos have great resources to see how to do the common stuff in Zig. That's awesome, Diamond. Thank you very much for that link. Albedo is base color plus ambient occlusion. Yeah, so ambient occlusion for us is separate. I assume you meant, yeah, diffuse, yeah. Albedo usually is the base color. My display of smartness backfired. Yeah. Yeah, so a lot of people just call it albedo, right? But like, yeah, that's just, I like the term base color. It just seems to work pretty well. And it's not bound to a certain model, right? Because I don't want to have it called different things for different lighting models when it's kind of the same thing. It's a more vague term, exactly. Yeah. More generic, I guess. Yeah. All right. So, like, normal map is a thing. Like metallic roughness, ambient occlusion, like specifically these two. You know, those are PBR specific, but they wouldn't be used on another lighting model, so I'm okay with that. Whereas base color could be used for like Fong, it would be diffuse, versus PBR it would be albedo, right? Which I suppose I could just, you know, have a couple of these all pointing back to base color, right, and have them be the same, but like I could do, I suppose I could do that, right? If you really wanted that, or, you know, we could do that, right? And then diffuse as well, right? And then just internally, I would just look for this one. Question, is this a good way to pack textures? Image 1 albedo, RGB opacity, image 2 normal, RGB height map. Height map is R, image 3, AO is R, metallic is G, roughness B. Image 4 would be emissive, RGB. Let me reread that again. I think that makes sense. But yeah, it doesn't format, so it's a little hard to read. Height map is A. Okay. Oh, I see. Wait a minute. Okay. It's actually kind of hard to read that way, all in one line. So image 1 consists of albedo RGB, and the opacity is A. Okay. Image 2, the normal is RGB, and the height map is R. Image 3, AO is R, metallic is G, roughness is B. And then image 4, emissive RGB. Yes, I think that makes sense. Although, you could also, well, yeah, I guess RGB makes sense for emissive. I'm doing RGBA, but I might not need the A. But yes, that makes sense to me. Yeah. You could stuff the height map into the alpha channel of the normal map. I think that's what it's doing, isn't it? Oh, wait. Wait. Image 2 is... Yeah, because... Oh, yeah, that's what you meant by you were saying height map should be A. Yeah. Okay. Transparent emissive sounds whack. Yeah, I was thinking like I might use it as like a intensity, but I don't think I need that. Yeah, okay. I got you, Diamond. Yeah, that makes sense. That makes sense to me. So yeah, I guess we could do this, right? That way in user code, we could say, well, hey, we want the diffuse, or we want the albedo, but it's really just base color. Okay. We're probably going to add more of these. But for now, this is what I'm going to go with. So, render default texture. So let's go back to... we actually need to go to the renderer system state. And we want default textures. Registered from the texture system. All right, and we'll circle back to that in a minute. Okay, so what this is going to be is, I think we can actually use handles for this as well. So khandle. I'm going to say default textures, and then we'll do renderer default texture count. And then it'll give us that. And then what we'll have to do is we'll actually have to set up a function where we can register these. So I guess let's do this in the header file. That'll help me figure out where to actually put it. Within the system itself. So this is where we acquire texture resources, right? And that ultimately gives us a handle. So I think, let's see, we have acquire, release, resize. Here's all the right stuff. We're not going to have to do this too often, so I feel like I could put it at the bottom here. We also have this texture internal data, which I don't think we actually are doing anything with that anymore. I think that's something I needed to kill and just haven't yet. Begin rendering. I think that might be something left over I have to do. Oh, the Vulkan swap chain needs to have that updated as well. Those should all be handles, so we're probably going to have to change that. Let me just go here real quick. Color datas. Yeah, and actually I removed the code that relies on that, so that can actually go away. Let's see. Do we have anything else? There's one more thing in the swap front end, which is just a forward declaration, so that can go. Okay. All right, so this, I think, was already removed. Yeah, it was already, its actual implementation was actually removed, so let's get rid of this. That doesn't belong there. Okay. So what we'll do is we'll do KAPI. This can be void, and we will renderer default texture register, right? Struct render system state, and then khandle, renderer texture handle, and we should probably specify here renderer default texture. Which default texture we're actually registering, right? So we basically say renderer for this texture, use this, and then that'll render, or that'll register that internally. So registers texture registers a texture with the given handle to the default texture slot specified. Param, I'm just going to do default texture, the texture slot to register to render texture handle, a handle to the texture to be registered. And then we don't return anything, and I'm just going to grab this param here. Right? I can grab this, go into the implementation, and then I'm actually going to do this, right, minus this line. And we're going to say if state, and we don't have an invalid handle, then we'll go ahead and do the thing. Otherwise, we're just going to ignore it, I guess. Our texture system will actually be responsible for doing this. User code's not going to do this, so I'm not too worried about error checking. So what we can do is state default textures sub default texture equals render texture handle. Right, and then we essentially call this from the texture system after we create our default textures. We'd call it once per slot, and then we're good. I suppose what we should probably do also is up here where we're actually doing this, we should probably actually invalidate all of those. So for u32 I is less than default texture count, render default texture count, plus I, and then we can do state default textures sub I equals k handle invalid, right? Okay, so we can do away with that and then just say invalidate default texture handles. They should be registered from the texture system via that. Right? Okay, the other thing that we're going to need is we have the register, so we also need the ability to get that, right? So we're just going to do khandle and default texture get, and all we need is the default texture here. We don't need this check, obviously. And what we're going to do is here return default textures, default texture. So that's, again, just going to grab the handle. And if we don't have state for some reason, we're just going to return khandle invalid. Right? We need to move this to the front and header. Export that. And I'm actually just going to copy this because it's going to be surprisingly similar. All right, so gets a texture handle with the given with the default texture slot specified. Yeah, that makes sense. Okay, pointer to the states, default texture, and then here this is just going to be returns a handle to the texture, to the default texture. Boom, done. Okay. It worked, although it runs at 14 FPS. That's not surprising because we have not optimized a lot of stuff. We're going to do an optimization pass at some point, but we're doing a lot of really heavy things, and the testbed is deliberately doing heavy things on purpose. So I don't know which branch you're running, but if you're running the 8.0 branch, the release 8.0 branch, which is kind of the current release that we're working on, that actually has a water plane that technically causes the scene to render 3 times, just because of the way that water works. But that Sponza scene there has almost 400 submeshes in it that we're rendering at a time, and we're not using instance rendering for that. And then we're also, we have that terrain, which is kind of heavy because of the high resolution textures that we have on it. Texture LOD is probably going to be one of those things that we're going to need to handle at some point as well. But yes, I'm glad it worked. It also depends on what the hardware is, right? If it's an iGPU, I don't expect it to run too fast. But there's a lot of things we need to optimize still. Okay. So this is what Blender shaders look like behind the scenes. Kind of, sort of. Yeah, it's just like we're setting up a configuration for that so that we can write text files essentially to configure them, and then load them up. Eventually, we're going to have our own sort of kind of an averaged shading language that takes from GLSL, HLSL, and MSL for metal. I forget what that one is. And we're basically going to just translate to those things under the hood, depending on what backend we're using. But that's a little ways off. So right now we're just using GLSL for everything. After how much time, you suppose, can we work on a simple game for the engine? So technically on version 0.71, which is the current released version, you could build a game on that right now. It wouldn't be optimal, just because you'd have to do a lot of work in the application to actually make it work. But we do have, obviously, we do have scene support. We do have, which comes with a PBR renderer. We do have things like cascading shadow maps and stuff like that. We do also have sound. So one of the big things that we're missing that would probably block you from a lot of types of games is physics. And we're not even going to have that for our first game that we're going to make with this. But eventually we'll be adding that. But that's kind of a large deal, and I don't want to hold off making our first game with, because of physics, because that's a huge thing. But yeah, technically speaking, you could use 0.71, which is the current release. You could use that now to create a game, and you could use the testbed as a template on how to do that. It's not very well documented because it's not really meant to be used that way, but you could do it for sure. Okay. You could store emissiveness as RGB E. E is for exponent if you're doing HDR lighting. Ooh, yeah, HDR is one of those things I want to add at some point too. That requires some swap chain changes though on my part. Or at least not necessarily swap chain changes, but not rendering to swap chain images, basically. Which right now we're rendering straight to those, and that's not going to work so well for HDR. Okay. So we have that. So what I'm going to do is I'm actually going to hook this up on the Vulkan backend first, and then I'm going to go over to the texture system and register those textures. We don't have all of them yet, but I think we'll have enough to get us started, right? So we'll be able to resolve this guy. All right, so what I'm going to do in this case is I'm actually just going to change this to say renderer default texture get. This is going to be context render. Wait a minute, what was that? Oh, do we have backend front end state? There it is. All right. Render default texture. And we're going to use base color for this, right? And so this changes from a fix me to a to do. Oops. And we're going to say make this configurable so that we can choose what default texture gets picked, right? I don't know how we're going to approach that yet, but we'll figure it out. We might have some sort of thing that gets exposed to say when we load up a texture to use this default instead. And maybe that's how we'll handle it. I haven't really fully decided yet. But that's not important because we can always change this binding later on and we're good. Okay. So we have that. All of the errors in this file have been resolved. So that was the last thing I think in the Vulkan backend that I need to do for now. Let me build. I know this is going to fail in the... It's back to actually the static mesh system. Okay, so this is actually, that's going to rely on the material system being finished because it's during the acquisition of materials, right? Material system acquire right there. So we can't resolve that error yet. We need to finish the material system and then we can circle back to that. So material system. So what we're doing is, this is kind of where I left off, right? We have these sort of default material shaders. And we'll see here that our state has three things. So we have standard shader, water shader, and blended shader. So this, you'll notice, does not match up with the material type. That is because if we take a look at, let's see. If we take a look at K-resource material, we now have a couple new things in here. We have material type and material model. And I'm actually going to go to definition on these guys. Material type is just what we have in our material system, right? So we have our standard, our water, and our blended. So standard is basically going to encapsulate, this is a standard type of material, right? It's the type that most like static meshes and things like that are going to use. Water is a special type of material because of the way that it acts, right? It's got different properties from a standard type of material. And then we also have a blended material, which is a specialized material in itself that can take multiple standard materials and blend them together. That's something that we haven't tackled yet, and I'm not going to tackle that right away. That is basically going to be the replacement for our terrain material, but we're going to have to handle that a little bit differently. So the way that blended materials are going to be handled is going to be done after we're done with all this refactor. I'll come back and revisit that because the only thing that is actually used for is the terrain, and I can shut that off for now. So in order to, kind of keep the scope down, I'm just going to stick to these two for now. And we're working on standard at the moment. So that's material type. This basically is a one-to-one with a shader, right? So there will be a standard material shader, a water material shader, and a blended material shader. And then further down, we have something called a material model. This is what you can think of as the lighting model for a particular material itself, right? So we have the type, which determines the shader, and then within each one of those shaders, we'll have support for different lighting models. So we'll have unlit is basically just it's going to just render just the base color, and that's basically it. Versus PBR, which is kind of our go-to material type for everything now. So that's sort of the default, if you will. Like if we're thinking about a default material, it's going to be a standard PBR material, right? We also are probably going to put Fong back in as well because that's a lot cheaper to calculate, and we don't necessarily need PBR for everything. So we may be able to get away with Fong, or maybe that's just a stylistic choice. So we're probably going to put that back, but again, not right away. So the first one that we're going to focus on is PBR, then we'll add unlit. And then that's basically it, right? Now, you'll notice here that there is for each of these, there is a type count, right? And then there's a type custom, and there's a model count and a model custom. And the reason that they're in that order is because the count will say everything above count is basically the known material types to the engine. Whereas custom means we have a custom shader that we want to use for this, and then that would be provided in the configuration that we want to use that custom shader. In addition to that, we also have a custom material model, right? So for our standard, water, and blended, we're not going to support custom model, but for a custom, we may have support for PBR, Fong, and custom, right? So our custom can use any one of these things or not, right? And so having these split out affords us a lot of flexibility, but also keeps us from having a million shaders all over the place. So we're basically going to wind up with, right now, 2 shaders that are going to encapsulate 2 lighting models each, eventually a third. All right, so I hope all that makes sense. Let's see. I got the Vulkan triangle from nothing for the 3rd time. Celebrate, I guess. Nice. I mean, when you're talking Vulkan, though, that's a long journey to get to that point. Classic 700 lines of pain. Yeah. Yep, exactly. Are you going to do just simple lit for 2D, like a lit sprite? Yeah, so 2D probably won't use materials, right? Materials are more of a concept of something that exists in the world, right? So like something that's 2D, like even like a 2D tile map or something like that, doesn't really need materials, right? That would be like a sprite shader. That would be handled completely different outside the material system, outside of all of that stuff. If you wanted lit sprites, again, I feel like that would also be a bespoke shader for that, and a different way that would be handled. Now, if you're talking a 3D sprite, like a billboard or something that's in the world, that's different, right? We probably are also going to have, we might also have like a blend mode as well. I haven't really decided how I'm going to do that yet, but for like particles and things like that, we're going to have to have probably a material for that. Well, particles, I guess, don't really have to go through the material system either. They could, but they don't have to. I guess we can make that decision when we cross that bridge. That was one mistake that I made early on, is I tried to make everything go through the material system. We used to have this concept of like UI materials, and I ultimately decided that didn't make sense. And so now my thought process behind materials is the only thing that materials apply to is tangible in-world objects, right? And that's basically it. Singy, how's it going? Good to see you. That's nice. I kind of stopped working some time ago, coming back to your streams here and there. Did make my own engine in Java using OpenGL. It's 2D and my first engine, but it works. And that is the important part, right? It works. Nothing wrong with that. Everybody has their first engine, right? For sure. Just because it isn't fancy, or just because it's 2D, doesn't mean it's not worth anything, right? That's invaluable experience, and it's great to build on top of, and you learn things, and you learn what to do and what not to do. Okay, so we have our cache handles for various material type shaders, right? So I guess we should do, let's call this, actually I need to rename this. Let's actually rename this material standard shader. And, whoops, material water shader, and material blended shader, right? That's a little bit more descriptive of what we're doing. And so we have this internal function here, just get shader for material type, right? We're going to have to do that probably several times throughout this code. And so we just map the shader to the material type. And then we have custom here that just throws an assert that it's not implemented, right? Because that's custom materials are going to be a whole can of worms that we're not going to open right now. Because they're going to be open-ended materials that are going to be very much different from anything else, and even programmable probably. So we don't necessarily want to jump into that yet. So these are sort of the known material types, mappings to their shaders. When we come down here a little bit, when we initialize the material system, we go ahead and we get these default material shaders, right? So we'll say, I guess we have shader name standard, shader name water, shader name blended rather. And if we go to these are just internal defines, internal to material system C. And I think we should probably actually name these. So let's do, instead of shader name standard, let's do material shader name standard. Oh, it's not going to let me do that. All right, I'll just do it this way then. Right, we'll do that, and then we'll do shader. Why is it? Okay. We'll do shader dot, I guess, well, let's call this, oops. I was wondering why it was acting weird. I had caps lock on. Material standard, right? Material water, material blended, right? And so these will be things that are included with the runtime package. We'll always have those available. Okay, so that's gonna break this down here. So let's just put that in. Okay. And so that's basically when we start up the material system. The material system is launched after the shader system is set up, so we should already have the ability to grab these things. So as a reminder, shader system gets will kick off the loading of a shader if it isn't already loaded, right? And it loads that by name, right? So we go ahead and create a K name for that, and then pass in that string, and then we go ahead and load that up, right? So we do that right away. And then when we create a material, and I've actually done some work on this, I have this new sort of static material create that I'm working on that's going to replace the stuff down below. And so the way that this works is obviously it takes the system state, and then it takes a K resource material, which is a typed resource. So this you can think of as configuration for material, right? So it contains all this stuff that we were talking about, where we have the type, the model, some flags here, right? So it has transparency, whether it's double-sided, receive shadow, cast shadow, using the vertex color as the base color. We have the ability to provide a custom shader name for custom materials, right? And again, it's not supported, but like this is how we would kick that off. And then we have our base color and our base color map, right? So you could either use the vector 4, or you could use the texture. Same thing with normal, and you can even disable that if you want. And then we have metallic and roughness, and those also allow you to specify a source channel, right? So RGBA for those. So metallic roughness and ambient occlusion all do that. Ambient occlusion can be turned on or off. MRA is the combined metallic roughness AO value. So it's either a value or a map, just like the other ones. And whether or not we should use MRA over using the separate maps, right? So whenever we can, we should be using a combined map, but we don't have to, right? So that's an improvement over the previous system as well. And then we have our emissive map down here, or emissive value, and then we have our custom sampler count and our custom samplers. So the custom samplers is just configurable right now. We don't have a way to actually apply those, but that'll be a later enhancement that we add. So taking that was basically loaded from a material asset. And we go ahead and translate all of that KSIN file, all the text in that file to that structure. And that's what we use to then create the material. So we go ahead and we grab a handle to that, which is that's what all this is doing. And then we go ahead and we get the material type and model. This does a little verification on that, converting the types from the resource type to the actual material type. Then we go ahead and we select a shader, right, using that function that we talked about before. Make sure the handle is valid, right? And if it's not, we return an invalid handle from material crate, which basically says this creation failed, right? Otherwise, we go ahead and we create the handle using the ID that we generated up here. And then we go ahead and we go through and we take a look at our configuration, so to speak, and we determine whether or not we're going to use the texture or the base value, or the value, right? For those that have it, we parse our material flags based on the booleans, right? So normal enabled, we actually have a material flag for that, and all of those booleans basically get condensed into a single integer, and then we can pass that over to the shader and unpack it over on that side. So we process all of our maps, our metallic, roughness, ambient occlusion, and or the values from that, depending on how they're set up, or the MRA, right? So if we have the MRA specified, it's going to override these other guys, and then emissive map, and then all of our flags, right? And then we'll go ahead and we'll create a group for the material. So this is one of the reasons that the shader system needed an overhaul, is because we had this really weird, super complex way of setting up texture maps with sampler information and texture information in order to actually create a shader group or a per draw ID for a shader, right? And so all of that wasn't really necessary, because we could just look at the actual uniforms within the shader and say, hey, based off of these, based off the frequency of each of those uniforms and what type they actually are, we could extrapolate all of that information that we were having to sort of generate before. And so I did away with all of that stuff. And now to acquire a group or a per draw ID at those different frequencies, update frequencies, right? All we have to do is call an acquire, right? We pass the shader handle and a pointer to a U32 to hold the ID, right? And this is all that's required, right? So the old material system, do I still have an example of it here? I wonder. I might have gotten rid of it. Might have gotten rid of it. But it was basically this whole convoluted process. Let me see. Let me do... I can't have deleted all instances of it, right? Let's see. Let me see if I can find one. This, right here. So we had to set up this sort of texture map structure, right? Get the shader, set up this configuration object, say how many texture maps did we have? Here's an array of maps. How many uniforms did we have? Here's an array of those. And then pass that over, right? This was just crap, right? And this instance, the shader instance resources, right, is now the per group, right? So all of this, and there's more complicated versions of it than this, right? For ones that have multiple groups of maps and stuff, this actually got complicated pretty quickly. Actually, let me see. See if I can find another example. So I think that's the one we just looked at. So UI controls really only use one, right? Yeah, see, like this one, for example, this is the shadow render graph node, right? So we had to get group resources for a shader here and here, right? Which is just poop, right? When we had these separate calls to like texture map resources and instance resources, and they both had to be configured, rubbish, right? So we got rid of all that, and now it's just now it is just this, right? And I put a to-do destroy release in here because obviously we set some stuff up here that would have to be released and whatnot. But I can come back to that. Arvis, how's it going? Thank you for the hydrate redeem. Appreciate that. 10 stream streak. Nice, Smudge. That's awesome. Appreciate that. And a stretch redeem. Ooh, my elbow popped. Awesome. And my shoulders popped. That's how you know you're getting old. When you stretch and everything pops. Okay. All right. So, I believe this is actually everything that we need to do to create a material, right? So, as a reminder of how materials work. So, when we set up the material system, we have these individual shaders, right? These have what we call per frame or global data that needs to be set, like a scope, right? Or an update instance, right? So, or updates frequency. Sorry, wrong word there. So each of these shaders have an update frequency where they have per frame, which means that particular thing is updated once a frame. Per group, which basically is like we have the standard shader, and then for each material that we have, that would be a group. And then we also have a what we call per draw. And those are per sort of instance of that material properties, right? So you can have the same material in two different objects, but maybe one object is animating the UVs or something, right? And so what that allows us to do is have those separate update frequencies nicely separated so that they're easily updatable, and we're only updating what we need to update at a time, right? So each of these shaders have that stuff. When we create a new material, we're creating a new group, right? And so that's ultimately why we're creating the group here. And then when we create a material instance, we will be creating a per draw set of resources, right? Okay. So let me see. Is there anything else? So we applied all the maps, values, all that stuff. I think that's all that's actually needed for for creation of a material. We could like custom samplers or something else that we probably should go ahead and grab. But I'm going to leave that for now. We'll come back to it. We do have the configuration for it, but the hookup for that's going to be a little bit more work than I want to chew off right now. I kind of want to get everything working with generic samplers first. All right, so material system initialize. So we have create default standard material, create default blended material. We should probably also have create default water material, right? Let's actually go to definition on this, and we're going to do, we're going to specify this real quick. So, okay. And we can actually go to, we'll go to the end of this one, which obviously we have a lot of stuff in here to fix, right? To do. Okay. Now, we got a big old blurb of text here for, we call this multi-material. There should be blended material. So obviously we'll have to change that, right? We still have references to like the terrain shader in here and stuff. So all that stuff's got to be renamed. So we can actually cover, we can either do this, or I think what we should probably do is finish the initialization first and just make sure that we're doing everything we need to do as far as initialization goes first, which is just creating the default materials, which one per material type should be fine. I think that makes sense. Okay. So actually that looks pretty good. Material system shutdown, we should probably handle that as well. So release default materials. Oh, you know what? We don't have a material release. So that's essentially going to do the opposite of what this does. So what I'm going to actually do is I'm going to take this and I'm going to copy it. And we're essentially going to undo everything in here. Right? So this is going to be return type, whoops, void. And instead of a typed resource, this is going to be a K handle material, right? I guess we could say handle, fine. And then what we'll do is we don't need this, we don't need any of this stuff. Instead of resource index, which is something we were generating before, we're going to want to get the state materials material handle, and we're going to say handle index, right? And we get the address of that, and bam, we have a pointer to our material. Now, before we do that, we should probably say, let's see. Didn't I have a way to... I could have swore that I had a way to compare this, but I don't think I actually do. We should probably have like a validate function against a U64 unique ID. Because I feel like I'm doing this all over the place and I'm having to do it like in line. So let's do K handle. What's the opposite of stale? I don't want to say valid, right? Because it could be a valid handle that's gone stale. Nivimi, how's it going? Good to see you. Fresh, yeah. Fresh is kind of a weird word, though, for that. You're old when you start saying things like, I didn't even know that could pop. Oh, yeah, that happens to me almost on a daily basis. Something new is always popping, for sure. I don't really like the word fresh. It's kind of right, but not 100% there. U64. Unique ID. I don't want to say is not stale, right? That sucks. Let me, you know what? Let's look up fresh in a thesaurus. Right. Pristine, I guess. Mint. Uncontaminated. See, I even have stale in here. Let me actually click on stale. Wow, really? Well, that's awesome. Okay, that link doesn't work, apparently. Okay. Apparently their site's having issues. All right, so I guess we're going to go with... I think pristine is a little bit better. Yeah, Navy me. I'm not going to use that one. Yeah. Or this one, you know, like what? No. That is not what I'm going to use to define a handle or describe a handle as not being stale. That, no. Currently trying to write my own Wayland toolkit, but it's harder than I thought. Oh, I believe that. It's probably why good ones don't really exist yet. All right, let's go with pristine. I don't really like that word either, but you know what? Let me actually... Let's see what pristine comes up. Yeah, it's the same thing. Okay. All right. Well, I guess that's that then. Pristine it is. Oops. Indicates if the handle is pristine, i.e. not stale, outdated. And all we have to do, right, we already have a invalid check. So all we got to do is return handle.uniqueID equals, oops, uniqueID.uniqueID equals uniqueID. Right, so now over here we can say if not invalid and, I guess, yeah, we should probably have a valid, right? Not invalid kind of sucks too. So I guess let's do khandle is pristine, material handle, and then so in order to pull this up, what we have to do is we have to say state materials sub material handle index unique ID. Right? And actually, we want the opposite of this, right? So actually, oh, you know what? We probably do need the stale check. Let me go in here and actually just to make this a little easier to use, right? We're going to say is valid, right? And then let's see. I'm actually just going to copy this one. And is valid. And we're going to say handle index is not equal to invalid ID. And unique ID is not equal to U64. And then we'll do oops. Handle is stale, right? Indicates if the handle is stale, outdated. Because we really ought to have, you know, in both directions, right? Let's actually just do this. So stale, and then we'll say, whoops, that should be double equals. That was almost a bug. That should be not equal. Okay. So what we can say here is if invalid or handle is stale, then material attempting to release material that has an invalid or stale handle, and then return. Okay. So I'm just trying to think if that covers our bases. So we do the invalid check first. That way we don't have like a huge value checking this handle index, right? So doing it in that order should be fine. Okay. So we don't need to do this, right? We could just zero the memory after that. We do need to select the shader. I suppose if we select an invalid shader, there's not much to do about it, right? We'll just warn about it, I suppose, if we hit that. Attempting to release material that had an invalid shader, I guess. Fine. Good enough. We'll know what causes that if we hit it. Okay, so the handle, we want to invalidate the handle, but we need to do that last. So we'll get rid of that. And then what we'll do is, the only thing we really need to verify on this is if khandle is valid, right? And that's going to be material base color texture. If it's valid and pristine, right? So we're going to do base color texture and then material unique ID, right? So if it is both of those, then we just need to release, right? Base color texture, isn't that? Oh. How do we... I didn't think we were keeping pointers to textures there anymore. I suppose that does make sense. Texture system. We have request. Don't we have a release in here somewhere? Release resource. Yeah. I don't know why that's not showing up on my... Okay, so this actually is a little bit simpler in this case. So material, material, base color texture. Okay, so actually we could just do this. We probably are going to do away with this pointer at some point, but since we haven't yet, since we haven't yet, we'll just treat it like that. Okay. So if we have a base color texture, we're just going to release that resource, right? And then this handles all the reference counting and all that stuff. So we'll essentially just need to do the same thing here. So material, normal texture, right? I suppose I could have just copied this block. Right, so we need to, I guess we don't need all of these, right? It's kind of obvious what we're doing here. Material flags we don't need to worry about. Metallic maps next. Roughness is next. Roughness This texture rather. AO texture. Emissive texture. Okay. So that should be all the text. Oh, we need MRA texture is the last one. That needs to go above this. Okay, so we release texture resources. Okay, so that eliminates all of this. Let's see, the flags we also don't need to worry about. And then we basically just have to undo this group, right? So, ooh, this should actually be material destroy. Okay. So, release the group for the material. So this is going to be, instead of acquire, it's going to be release. I think that returns, no, it does return a Boolean. Okay. And then instance ID is not address of, it's just that failed to release, right? But this is not going to be an error. If we fail on releasing, there's not really much we can do about it except bleat, right? So we release that, and then to do custom samplers, we're going to have to release those as well, I think, potentially. So I'll leave it there. Okay, so that is about half of destroying a material, right? I think there might be more stuff. Let's see, what else is in here? Are there any arrays in here? I don't think there are. No. Okay. So what we can actually do is we can zero the memory. So we'll say material and then size of material data. Right, so we'll zero that out. And the only other thing we'll need to do is invalidate the handle. So actually, since we're destroying this, we actually need to take a pointer to the handle because we want to modify that handle, right? So we need to dereference the handle here and here and here. Okay, and then let's see. We still have material, so material unique ID needs to be invalid ID U64. So that'll mark the material slot as free for another material to be loaded. Okay, so that's how we mark that as free, and then we can do k handle invalidate passing, and that takes a pointer to the handle, so that'll be material handle. And then I'll mark the handle as invalid too, which will generally be owned by the material system itself. Okay. I think that is pretty much standing up and shutting down a material. In terms of just trying to think here, the only other thing we need to do is create our default materials, which we're going to have to create configuration for those, which we already kind of started at the bottom. That creation or the configuration will eventually lead to the creation of this, which we will then use to stand up a material. And then we also need to handle material instances. So that's those completed. Material system shutdown. So our release default materials. We need to destroy default materials. So we'll say material destroy state. And then we're going to do the address of state material standard shader and material water shader and material blended shader, right? And then these two go away. And that's our shutdown. All right. I will read that comment after we come back from ads. I just realized we're on an ad break, but it's only got like 12 seconds left, so I'm not going to bother pausing. I'm accomplishing too much tonight to pause for ads. I think Qt has pretty good Wayland support, and it is better than a lot of options, but it has very high-level abstractions, and I just want to learn Wayland, not Qt. Yeah, I would agree with that. Plus, we need more people doing Wayland implementations of stuff, because there's not really a lot of great examples out there that are open source that don't have, crap tons of abstractions to pick through. Okay. So this material resource loaded. Material instance listener. What were we doing here? I think this never actually pieced itself together, right? We were doing a whole bunch of weird bananery here. Talking about IBL probes. I feel like a lot of this can actually just go away. Because this is kind of how our resource system works now, without the need for all of this. So let's see. Material resource loaded is going to be called back whenever we load a material resource from disk, right? i.e., an asset or whatever. So when we create one of the default materials, or we create any material, but let's talk about let's talk about both. So when we create a material, or when we load up a material, we say, hey, get a material by this name. The standard process for that is to say, okay, here's the name of the material we want. Reach out to the resource handler for that. That will in turn reach out to the asset system, which will reach out to its own asset handler for that type of asset. It'll load up the asset from disk, pass that data back to the resource. The resource will then do whatever processing it needs, if any. And then once that is loaded, a callback would essentially be issued. And this is that callback for material resources. We have a lot of that stuff set up down here. It looks something like this. And so that's the process for a standard loading of a material off disk by name. That's the sort of acquisition process that we have here. The default material acts a little bit differently. So the default material, like our default standard material, default water material, default blended material, what we actually do is in code, we create a material configuration here, which obviously this is going to have to be much, much different now because we haven't updated this since we changed our file format. But we essentially emulate the asset stage already having happened, right? And we just load raw text. And then we say, okay, the asset's already loaded, just, use this text to stand up the material. And the resource handler for materials takes that and processes as it would as if it loaded an asset off disk, and then issues that same callback. And see, this is the type of crap here that we were having to deal with before, and this is why I said we need to actually factor this now. So a lot of this we don't actually have to do. We issue our, let's see, our callback is, yeah, there's, let's see, a resource system request. In the info itself, we haven't actually set up a callback. So we need to do that as opposed to doing it inline here. We could do it inline here because it returns immediately, but we're not going to do that. We might as well take everything through the same code path, right? Okay. The other thing that can disappear is all this assign map stuff. We don't need any of that stuff anymore, which is great. I haven't deleted it yet just because there might be something in there I need. Okay, so material resource loaded. The only thing that I can think of here... Oh, that's right. We have this material instance listener. Okay, so we need some sort of context whenever we load a resource, right? We say, what material is this actually for? Which actually, we had this sort of material instance thing, which is not actually what that is, so I'm actually going to delete that. Really our listener isn't anything more than a handle, actually. Let me think about this for a second. So we need some sort of like listener object to say, hey, this is the thing that we're talking about. I don't think we actually need that, though. I don't think we actually need that context because we haven't actually stood up a material yet. I think all we literally need to do, delete all this and go material create. Oh, the listener might actually have to be the system. Let's do that. Listener, right? Because we need the state. So we'll get the state that way. And then the typed resource, the K resource material is just going to be typed resource. And then this returns a handle. I see. This isn't quite so simple. Okay. So thinking about the life cycle of this thing and the way that all of this needs to work. Whenever we acquire a material, what we're really acquiring is a material instance, which is sort of that per draw level stuff that we were talking about. So if we think about that, what would be the flow of logic if we were acquiring a instance where we say we want an instance of a material called this, right? But that material isn't loaded yet. Then what we have to do is we have to asynchronously reach out to the, let me think. We have to reach out to the resource system, load up that material resource, which is an asynchronous process, right? So it can happen at any point, and return at any point. And then that at some point will come back with, hey, I've loaded the resource, and then we stand up our material. And at that point, we can actually create the instance of it, which would need to be ultimately referred back to somehow. So this material system acquire is going to work this way, and it is going to use handles, but not exactly the way that I initially planned. Thank you for the follow, by the way, and welcome. So my thought is, we actually have a material instance structure, which we kind of started outlining here, but never really finished. And all that material instance structure is going to hold is a handle to the base material and a handle to the instance. And using those two handles, we should be able to get any of the data that we need. That'll solve our cross lookup issue where we can say, hey, we have this material instance. What's the base material? We have a handle to it. And then when we go to acquire, we set up a listener that includes handles, that pointers to the handles for both. That would get updated when the actual thing is loaded. Let's see. Thank you for the follow, by the way. Appreciate that. Soulfoam in 2024. How's it going, Soulfoam? Good to see you. An actual stream to watch on Twitch. Awesome. Hope you're doing well, man. How's Rally coming along? I haven't had a chance to sort of check in. Been kind of busy, unfortunately. Let's see. So we have material data here, and then we have material instance data, which is going to be what the handle references internally. So we'll have a type def. Thank you for the follow. Appreciate that. Material instance. Right, and this will have a K handle to the material and a K handle.
New donation from Devon.
Thank you very much for the donation. I appreciate that. I didn't see what the amount was, but I really appreciate the donation. Thank you very much. Very much appreciated. That helps me cover the cost of stuff. So thank you for that. I don't know how to actually... I wonder why it didn't say the amount. I haven't actually had that pop up before. So I'll have to see if I can figure out how to make it say the amount. Yeah, I appreciate it though. Thank you very much. Thank you for the $5. I appreciate that. Every little bit helps, right? So I definitely appreciate it. Okay, so we'll say instance. I guess we'll say instance, right? Okay, so this is going to be handle to the base material, right? And a handle to the instance. This almost makes me think that whenever we actually request a material instance, we probably ought to set the handles up right then and there instead of waiting on the actual thing to finish loading. Because if we have two things that come in a row that request the same material be loaded, right? That's an asynchronous process that may not finish by the time that second request comes in. So if we set up the handles right away and return those in here, then at least if we were to acquire that material again, or another instance of that material, we would already have that thing set up in the actual array. As well as, well, not necessarily the instance, I suppose, but I think that's fine. Okay. So I guess what we really need to do is extract, we need to extract this bit where we find a free slot and create a handle here. This needs to happen like first. So I guess let's do, I'm going to do another static function for now. So I'm going to wrap this up in, material system state. And all that's going to do is this, right? And technically this. And then this bit. And then return handle. So whenever we do this, the handle will be created immediately. The resource array entry will be updated immediately with a unique ID from that handle that's created. And we'll have one right then and there. And then this material creates we'll just pass here. And then use that to say material data. I guess let's call this material handle. Material equals address of state materials, material handle, handle index. And then we can do all the rest of the stuff. And at this point, we actually don't have to do a material. We don't have to return a handle here. We'll just return a Boolean to indicate success or failure. I guess we could invalidate the handle too. I guess actually if we just invalidate the entry, that should be good enough. I'm not going to worry about it for right now. All right. Okay, so if we get all the way to the bottom of that, we'll return success. Otherwise, if we hit one of these other issues, we'll just boot out. Okay, so this now will take in a handle that's already created. So we don't have to worry about that other issue. $5 to you is greater than, or is better than $3 to you plus 3 to Twitch. Yeah, I definitely would agree with that. Like I said, I really appreciate it. All right. So when we go to material resource loaded. We need to actually come up with like a listener so that we actually have a handle for this, right? So let's think about this for a second. So we have this actual request info. That's the resource request info. We don't want out instance to be the listener. So what we really need is, let's say, up here, material request listener. Okay, and this is going to contain khandle material and khandle pointer to the instance handle. All right, so I guess we'll just call this material handle and instance handle. It'll also need to create or hold a material system states, because this goes through a system that doesn't know about it. So we'll need a copy of the state there. And that's probably, I'm thinking it, right? Just those things. And so all we should have to do is come down here to acquire. And let's see, we have a pointer to out instance, so that's good. We'll need to set up a listener. So what we'll do is material request listener. Actually, I don't even need. Calc type, and we're just going to do request listener and memory tag. Do we have one for material? Material instance? Yeah, I guess we could call it that. Right? So we set the listener state to state. Listener material handle to what did I call that? Material handle create. Right? We'll pass state to that. And then we'll do listener instance handle is equal to the address of out instance. Right? So we have a pointer to that instance handle, so that way whenever we stand up the material, we can then say, okay, well, we have the material, let's go ahead and populate the instance. This is created immediately. That resolves that problem. And then the listener instance becomes just listener. And then since we're having a callback, we actually don't need to immediately save off the resource, because we get the resource in the callback. So we can do request base user callback. Oh wait, I already had it here. Material resource loaded. Okay, so that's actually already set up. Okay, so we don't need this. We can just call it. Okay, I don't know what would ever cause us to return false here, but I suppose we could do right? And then we could just say R is not equal to 0, right? I guess we'll use that as our success. Okay, so acquisition is now solved. Material resource loaded is now solved. What we can do is go to this guy, and we can get the state instead of from the listener. We'll grab that in a second. Material request listener. Call this listener inst, and we'll just say listener, and that'll be casted to material request listener. All right, and then this is going to be listener instance state, right? And then material creates is, I think I actually have passed the handle here. So that's going to be listener instance material handle. All right, and that's a Boolean, I believe. Yeah. So if this fails, there's not a whole hell of a lot we can do about it, but we can at least bleat about it. Right, and we're going to early return out of that. So when we have the resource loaded, we do material create. There is one issue with this. We need to actually see if that material is already loaded first before we do this. Because that's a separate path, right? We only need to do this if the material with that name doesn't exist. So, I guess what we'll do is U32 material count equals state, DRA length state materials, right? For U32I equals 0, I is less than material count, count, plus I. Okay, and then we'll just say if state materials, I can type the right thing here, state materials sub I dot, do we really not save off the name? Really? Okay, I'll have to fix that in a second. Okay, so material exists, create an instance, and boot. Okay, so out instance material equals khandle create with U64 identifier. So we want to use handle index is going to be I, and then unique ID is going to be, you know, you should probably grab a convenience pointer here. Material data, address of state materials sub I. Okay, and then we'll do material unique ID. Right, so we can set that right away. I know we don't have the name yet, I'll have to fix that. And then we can go ahead and to do instance and set handle. I think your message got lost due to auto mod. I don't see an auto mod. Let me see. I don't see one. Normally it tells me. Oh, yes, there was one a while ago that got lost. Maintaining a community repo for a pretty small operating system called Ethos. Found out that I hate handling keyboard support. Oh, I feel you on that one. If you need to support default layer, shift layer, alt layer, shift alt layer, etc., just a pain in the ass. Yeah. Yeah, we've experienced some of that here. And that's with APIs to help you with that stuff at that level. Ugh, gross. Keyboard support at that layer would not be something I would want to mess with. Okay. The important part here is if we find the material, we need to boot out here and not actually load this, right? So material is not yet loaded. Request it. Okay. Let's see. When we do don't we have name as part of the base properties, I think. Yeah, we do. Okay. All right, so I guess we just weren't saving it. I could have swore we had that in here, but apparently not. All right, so we're not going to know. We'll set the name during the actual acquisition. So down here, if the name's already set, then we're good. If it's not set, then when we do the handle creation, we'll need to set it at that time. And I think, don't we actually, yeah, so let's actually just take a name in here. That'll be easy to do. Right, and then we could just do that. And then pass along name here. So again, that'll be, oh, wait a minute, no. Is that, yes, that's right, okay. Because we immediately create that before anything else is done, before the request or anything. So, okay, so we request the resource, pass along the name, so that's already set. So if we basically did one of these and then immediately did another one of these for that same material before this asynchronous process returned, we would already have the name set and we should be good. Thank you for the follows. I appreciate that. People with other keyboard layouts like Azerty want to use all of the available keys in kernel shell, but I can't add them at this point because simple BIOS VGA driver doesn't support accents and other things. Oof. Oh, you know what's going to be really nasty is when you have to do things like Japanese and Korean keyboards and stuff. That's going to be a whole thing. Because like even like that stuff's complicated even with an input method editor, but the actual physical keyboard itself, that's gonna be crazy complex. Because that's like its own layout. Not to mention the slew of European keyboards. All right. Okay, so I think our acquire looks pretty good. So I guess now we can actually handle this resource loaded, right? So we do material create. And then I guess what we need is material create instance, right? So that's going to be, whoops, not here. We'll have this be another static function. So we'll do, how do I want to handle this? I guess Boolean return type, right? Static. Material instance create, right? So obviously we'll have the material system state. We'll need a k handle base material, and then a k handle pointer. Oops, k handle. Out instance handle. And we should be able to get everything we need from that, I think. So just to circle back, so this is going to create the base material, then create an instance of it, right? We may need a Boolean to tell us whether or not to actually do that. Because I think with default materials, we're not going to actually want to do that. So actually, yeah, that's going to be the case. Well, I guess actually, if instance handle is null, we just don't create it. Yeah, that's what we'll do. So if listener instance handle, create an instance handle of it, or an instance of it if one is required, which is most of the time going to be true, but not always. Default textures or default materials are not going to immediately create an instance. So I guess we can do if not material instance create, right? That's going to take state. Base material is going to be listener instance material handle, and then we're going to do the out, which is going to be the listener instance handle, right? Which is a pointer to that handle, which is why it works here. If that doesn't work, then we're going to do k error, or I guess warn, right? Well, let's do an error, right? That's probably going to be an issue. Whoops. Failed to create material instance during new material creation. And I think that's actually all we need to do, right? Because this will actually set the handle and everything else for us. It'll work very similar to this, just for instance level stuff. So we have that. And we need to take this and also call that from here. And And I guess we could actually just say B8 instance result is that. And we can do instance result return there. And then let's see, do we not have... I guess we don't have a handle from this, so we'll have to create... Oh yes, we do. Out instance material. Coffee Lava with the tier 1 sub. Thank you so much, Pog. 5 months. I really appreciate that, man. Thank you so much for the support. Giga Chad detected. How's it going, Orshi? Max Dev, how's it going? Good to see you. Don't remind you of those? Yeah. So many different keyboard types. How are you doing, Coffee Lava? What are you up to? Noise. Okay, so this is gonna be out instance handle. Wasn't this... Oh, we need the address of this. Right. Okay. So this is no longer a to-do. And then, oh, if not instance result, then we bleat about it before returning. Okay. All right, so the way that this works is when we acquire a material resource, or a material instance, rather, we have to be provided this out instance structure here. This contains two handles, a handle to the base material and a handle to the instance when it's created. The way that this works is it then searches the material system to say, hey, do we have an instance, or do we have, rather, a material with this name? If we do, we go ahead and we create a handle to that, and set that base material handle in the out instance to that. And then we go ahead and we request a material instance, which sets the instance handle upon creation. If we do not have a material that matches that name, then we build up a request, a resource request, which is asynchronous, or is to be thought of as asynchronous. It's not asynchronous now, but it will be. With a listener that includes state, material handle, and a pointer to the instance handle, which is included in the pointer to the out instance. When that resource is loaded, material handle create, before we actually make that request, we set the material handle to create a new material handle right away. That way, in case we have two acquisitions of the same material name before the actual resource comes back, because again, that's asynchronous. That way we don't run into an actual issue with trying to load the same material more than once. So we immediately create that handle for the material if it doesn't exist, so that it exists in there even if it's not loaded. And then we perform the request. And then that eventually calls material resource loaded when it's ready to go. When the material resource is loaded, it will then create a base material. And then if a instance handle is created or is provided, it will create a instance of that. Okay, so now I can actually just use something very similar anyways to material system acquire in creating our default materials. It won't be this exactly, but it's going to be pretty much this section of it here. Okay, so that all looks good. I'm pretty happy with that. And I think the rest of it is going to be basically figuring out, standing up all of the instance level stuff for materials. We already have the base material, so all it is really going to be, I think, just requesting group resources for it. I don't think there's a whole heck of a lot else that actually has to be done. Standing up a data structure for it as well. Not a big deal. Then we'll need a teardown for that. And then we set up our default materials, and then the actual resource portion of the materials is done. And then we'll have to handle the shader aspect of it, which is another thing. So that is where we're going to actually end for tonight. But let me, before I end, I'm going to catch up on some comments here. Benaya over on YouTube, hello, how are you doing? Cole, good to see you as well. New to C and 3D graphics, should I just start watching to learn along the way, or should I learn C first? I would say learn C first, for sure. To follow this, you'll need to have a decent command of C and or C++. We use C here, but if you know C++, you'll probably be okay. But yeah, I would definitely learn C first and have a decent command of that, especially memory management when it comes to dealing with pointers and stuff like that, because we use the crap out of it. So that's where I would start. All right. I'm Motive, first-time chatter. Welcome. Been learning Raylib lately. Vulkan is on a whole different level. Yes, it is. Raylib is pretty cool, though. Also, repo admin plans to add graphics environment. And I can't even think about the amount of hard work that needs to be done to make this at least possible. Yeah, that's going to be probably the hardest part of the whole thing, right? I have been good, NK Coder. Pretty good. What distro is this again? It's Arch, by the way. Yeah, down there. So we use Arch here. I mean, I've got I have another machine that I'm going to install Ubuntu on just for testing purposes. But yeah, my main dev machine is Arch. All right, so that pretty much catches us up, I think. One more question. What series of projects would you recommend to learn C? Start small first, right? Start writing simple things like text-based programs, menu-driven applications, where you like print some stuff to the screen, say, hey, choose an option 1 to 4, and then input, right? Get familiar with that, then handle things like reading and writing files. Then I would move on to, I hesitate to say multi-threading because that's kind of a whole separate other thing, but like it'll take you probably a bit to get there, right? And then, maybe start learning like OpenGL or something. I would not start with Vulkan if you have no C or graphics programming experience. I would not start with Vulkan, even though that's what we're using here. The concepts transfer, but Vulkan is very verbose and exposes a lot more than OpenGL does. Let's see. Thought you were rocking macros. We do have some macros, right? Like kalloc type is a macro. It just does this. Just calls my kallocate. So it basically just shortens what I have to type. But I don't have a crazy number of macros in here. Macros, not macros. Oh, Mac OS. Wow, did my dyslexia just kick in there, hardcore? Yes, it did. Holy crap, I thought you said macros, and it's actually Mac OS. Oh, man. Okay. This is why, I usually have to read things 2 to 3 times before I fully understand it. Because I actually do have dyslexia, and it screws me up all the time. Thought I was rocking Mac OS. So, I do use macOS for my streaming machine, but this is actually Arch using Cinnamon. And the theme that I have just has these buttons, right? But if it was truly macOS, they would be over here on this other side. So yeah, this is Arch using Cinnamon. But my streaming machine that sits over here off camera is a Mac. So I stream on one machine and actually work on another. So that way, if something goes wrong here, especially with graphics programming, it doesn't like take down the whole stream. Let's see. Started by making a small utility function from standard library like string length, string join, sort, own linked list, then making utility program like hex dump, but only using write, open, read. Yeah, those are all good suggestions as well. Re-implementing like standard library stuff is a great way to learn a language for sure, because there's lots of stuff in there, especially when it comes to string processing for sure. All right. Yeah, reading fail. X hyped, first time chatter, welcome. All right, so let me find somebody to raid. And while I do, I would like to just say, if you guys aren't already, I would really appreciate a follow. I'm trying to grow the channel and encourage more people to get into game development and game engine development specifically, because I believe that the more competition we have out there, the better. And so I'm hoping to get people into this, right? So thank you for the follow, by the way. I'm just trying to find somebody that we can raid here on the Twitch side real fast. Kind of looking for something that's like loosely related to what we're doing here. I don't know that I'll be able to find it. Sometimes I can, sometimes I can't. Just bear with me for a second here. Oh, okay. I know who I'm going to raid. He hasn't been on this late in a while. So I'm going to raid Reinhardt. So he is making a game using C++, his own sort of game engine, if you will. And he's also making all the art himself. It's a tower defense game, and it's looking pretty good. So we're going to go ahead and move over to his channel tonight. And yeah, that's going to do it for tonight. So thank you guys so much for joining me. I really appreciate it. And I will see you guys on the next stream. See ya.